Hello, I welcome you all in this course on power plant engineering. Today we will discuss environmental aspect of power generation. In this lecture, I will be covering, first of all, I will start with the introduction, then pollution from thermal power plant, gases emission and control, particulate emission and control, pollution from nuclear power plants, hydro and solar power plants as well. It is about the pollution from hydro and solar power plants. Uh, all the power producing unit, I mean every power plant, it has impact on the environment, whether it is a nuclear power plant or a thermal power plant or hydro power plant or even solar power plant or any other non-conventional power system. All of them have bearing on the environment, right? And not bearing, in fact, it is a bad effect on the environment. So, and this pollution of the environment or disturbance of the environment is inevitable. I mean, we need power also, we cannot live without power. And for this high grade of energy, we have to pay cost in terms of decay in environment or damage of the environment. So, this damage of the environment has to be minimized. I mean, the power generation should be made in such a manner that the damage of the environment has to be, it should be minimized. It cannot be made zero, but it should be minimized. And in order to restrict the power generators to damage the environment, worldwide there are legislations. We are also having laws on the environment, right? So, no power generation unit can violate those laws on environment. Now, the pollution, first of all, from the fossil fuel. Fossil fuel plants, in fact, they damage, in some sense, they do a lot of damage to the environment, right? Because in fossil fuel plants, the fossil fuel, that is coal, which is normally coal is used and which is burned. When the elements of the coal they burn, oxides are created like carbon dioxide, water is okay, sulfur dioxide, NOx, X may be 1 or X may be 2, right? When there is incomplete combustion, there is NO, and when there is complete combustion, there is NO2. And many more other gases in traces which have been found in the flue gases. Flue gases, they come out of the chimney, and where they come out of the chimney and they mix with the environment air, and that is how they pollute the environment air. In addition to this, thermal pollution is also there. Thermal pollution by fossil fuel plant, because in the fossil fuel plant, when the heat is generated, entire heat is not converted into the electricity. Part of the heat is converted into the electricity, and a substantial amount of heat is liberated to the surroundings in form of radiation, convection, or with the exhaust gases. A lot of heat goes with the exhaust gases, right? So, this a localized heating takes place in the surroundings, that is also a pollution, right? So, a thermal pollution they make, and the particulate matter also is sent to the environment or surrounding air, and this particulate matter, when a person breathes, it goes into the lungs, and that is how without going to the lungs, it can also damage, because some of the elements, they are very poisonous in nature. Even they come into contact with the skin, it will cause irritation, right? So, these are broadly this type of pollution which is created by the fossil fuel plants. Though the technology has improved, many of the toxic gases, they are trapped before going to the atmosphere, and even the technologies are available when pure air is sent to the atmosphere. All the elements are, filtered out of the flue gases, right? But still, I mean, when these elements are filtered out, they will go somewhere in the nature. So, they are not going to the air, but they may be polluting somewhere else. And similarly, for a thermal pollution, if the plant efficiency is high, definitely the heat liberated will be less. In that sense, we can say that thermal pollution can also be reduced, but it cannot be made zero. Particulate material which goes to the atmosphere, if all the elements are filtered out, then particulate material will not be there in the air. But 100% efficiency is difficult to obtain. So, some of the particulate material definitely enter to the atmosphere. Another is nuclear power plants. In nuclear power plants, there is no exhaust gas because the heat is generated. If you look at the again Rankine cycle of power generation, which is used for in a, let us take superheat cycle, in a thermal power plant, fossil fuel plant, or a nuclear power plant, the cycle is like this. So, this process 4 to 6, it takes place inside the boiler where the fossil fuel is burned, right. So, this process 4, 5, 6 takes place inside a nuclear reactor where nuclear fission reaction takes place. So, there is no exhaust from nuclear power plant. But in nuclear power plant, there first of all, there is the issue of radioactivity. There is issues related with the radioactivity released, then radioactive waste. Disposal of radioactive waste is a major issue nowadays, right. We can use the radioactive material, that is okay for power plants, but when the waste which is coming out of the nuclear power plant, it has to be disposed of and it is highly radioactive, right. Here also there is a thermal pollution. Thermal pollution is there. Hot water, normally hot water is taken from the river, whether it is a fossil fuel plant or the nuclear power plant, hot water is taken from the river and for the cooling purpose, it goes back to the river. Temperature is increased in a range of 7 to 10 degrees centigrade and that high temperature water which is going into the river, they forbids growth of many of the microorganism plants and animals, right. So, it is not desired in fact. Now, again in a thermal power plant, the pollution comes through chimney, mean pollution comes through chimney, right. And this emission which is coming out of the chimney can be classified as gas emission, then particulate emission as I told you earlier, then solid emission, and fourth waste heat I have already discussed with you. Now, this gas emission is most troublesome, right. And I said earlier, the main is the sulfur dioxide. How to remove sulfur dioxide? There is another poisonous gas is hydrogen sulfide, right. And sulfur dioxide, what does it do actually? This is acidic in nature, sulfur dioxide. It causes irritation. If the sulfur dioxide comes into contact with your eyes, it will cause irritation in the eyes. If you inhale, irritation in throat, and it is corrosive in nature. Suppose it comes into contact with the pipe also, it will corrode the pipe. So, it is highly undesired gas in atmosphere or any gas which should come in contact with the human being. Now, another gas which is very dangerous is hydrogen sulfide. It has, a Berry syndrome, a disease Berry syndrome. Berry syndrome, the immune system of the body starts damaging its own nervous system. So, it is a very, severe disease. So, that is caused by H2S. H2S is one of the reason. Inhalation of H2S may be one of the reason for such disease. And it attacks your immune system. Then irritation in eyes and lungs in addition to that is done by hydrogen sulfide. Oxides of nitrogen, NO and NO2. So, and this also causes irritation and bronchitis. They directly affect the health of the human being. All these poisonous gases which are coming from the chimney of a thermal power plant. Most dangerous is carbon monoxide. Carbon monoxide, it is colorless and odorless. You can inhale the carbon monoxide and you will not come to know you have inhaled the carbon monoxide. Slowly it will absorb your, oxygen in the body and a person will become subconscious and subsequently may die. So, this is a very dangerous death. One has to be very careful about the carbon monoxide. In many of the houses earlier, I do not know now people are using it, that LPG based geysers. So, when they are fitting LPG based geyser and LPG is consuming air, oxygen from the air, extracting oxygen from the air in the bathroom, in that case sometimes it has been found that there was a scarcity of the oxygen and the person who was taking bath became unconscious, and this can be fatal also. So, one has to take care, one has to be very careful about the carbon monoxide, because other, if you go for the H2S gas, H2S gas will give a very pungent smell. You can immediately, sorry, H2S. So, H2S will give very pungent smell. You can easily identify leakage of H2S, but leakage of CO cannot be identified. So, how to remove H2S, or not H2S, sorry, SO2. No, previous, okay, SO2, not H2S. Sulfur dioxide. For the sulfur dioxide, scrubbers are used. You will find in many of the industries. I mean, not only power plant, in where the fossil fuel is burned, scrubbers are used, right? Or where the boilers are used for some other purpose, for example, glass industries, right? Scrubbers are used. Now, a scrubber is a sort of cylinder. It can have any shape, but it is a cylinder, and the exhaust or the flue gases, they enter from one side of the cylinder. In the center there is a pipe, right, and this is a perforated pipe. So, the water spray is made all around the surroundings. So, this place is filled with the tiny water droplets, right, and when SO2 goes with, enters the scrubber, and when it comes into contact with the water droplets, it gets filtered out from the gases, and here you get the gases, and it is not a straight motion, it is a spiral motion, and at the exhaust you get no SO2. SO2 remains, sulfur is collected here in scrubber, and later on it is collected at the bottom, and subsequently it is removed from the scrubber. So, not only one, there are number of scrubbers which are put in the industries to remove the sulfur, they call it sulfur from the exhaust of this fossil fuel. Now, in scrubbers, the gas, because sometimes you have to reuse this gas, but gas is cooled to such an extent that it has to be reheated. That is maybe one of the drawback of the scrubber, because this water is sprayed at the normal temperature. So, this is how we get rid of sulfur in the exhaust gases. There are other methods of getting nitrogen oxide. As I said earlier, NO2 what we can do, we can reduce its resident period inside the system. That one thing we can do, and what it does, it increases the equivalent ratio. Presence of NO2 increases the equivalent ratio in combustion chamber, and that is also not desired. So, the presence of NO2, otherwise, I mean, all the gases can be taken out, but it will increase the cost of the overall cost of the plant, right. So, mainly focus is done on the removal of the sulfur, because it is highly dangerous. Now, next is particulate emission. Now, this particular material you must have heard, or you must have seen in the news also. It is also quite damaging in for the health, and first of all is smoke. Smoke which is coming out of the chimney, it has particular material of diameter less than 10 micron, 10 micrometer. Very tiny particles are there in the smoke. There are fumes which are also dangerous. Fumes may come from the coal, or they come from the metal also as well. The diameter is much less than the diameter of the smoke. The fumes are also dangerous. Any kind of fume is not good, I mean, for the health. So, it can come from the metal also, right, and they are reactive. Sometimes fumes are reactive also, they do react with your skin, right, or with some metal. So, they are highly undesired. Number 3 is fly ash. Fly ash, disposal of fly ash is also an issue in a power plant, but otherwise fly ash is also another environmental hazard. The diameter of the particle diameter of the fly ash is approximately 100 microns or less than 100 microns. They are not more than 100 microns. 100 microns means 0.1 mm. So, you can see visually you can see the particles in the fly ash, and fly ash disposal. Now, fly ash is used now for by the construction industry. Construction industry is using fly ash for the purpose of construction or purpose of bricks or making bricks also, right. So, that is one of the best and the convenient way of disposing of the fly ash, making bricks and using it in a construction of the building. The fourth is cinders. Cinders have diameter of the particles is greater than 100 micron. Easily you can see cinders moving in the air and ultimately they get settled because they are heavier, they get settled. Collector efficiency, there is always a collector of emission. Collector efficiency, you can take a scrubber or any other device which is used for taking out the poisonous gases or poisonous material from the flue gases. So, it has certain efficiency, and efficiency is mass of the dust removed divided by mass present in the gas. Suppose m kg is coming, 0.7 kg is removed, right. So, efficiency is obviously 70%. So, it can never be 100%. Normally, scrubber can have 90% efficiency. Scrubber is a highly efficient system of removing sulfur from the gases. Now, if you go for the electrostatic precipitation, there is I'll explain you different systems. Electrostatic precipitation, that also goes up to 90% efficiency. Now, collector system. One is cinder catcher, right. In cinder catcher, what we do, we use the second law of motion, change in the direction of motion, right. For example, the cinder is coming with the gases in this direction, we change the direction of the motion, because in solid nature it will go here and the gas will move from here. So, that is one way. Another way, the cinder is coming in a pipeline, all of a sudden there is an expansion. When all of a sudden there is an expansion, it will try to stick to the bottom side of the expansion, and here you can provide a passage where it can be removed from the gases, right. And you can have number of arrangements. You can have, a fan, a blower type of arrangement as well, where air will enter from this side and it will leave from the center. When it leaves from the center, the cinder will be sticking to the wall of the pipe or wall of the collector where it can be removed, right. So, there can be many ways of removing the cinder from the gases, but it is not a very efficient system. Now, if you want to have an efficient system, you can go for electrostatic precipitator. Now, electrostatic precipitator Now, in electrostatic precipitator, there are number of plates, and these plates are grounded, and there are wires, hanging wires in between the space between these plates, right. And gases are blown, and the voltage in the wire is 30 to 60 kilovolts. Voltage is quite high. So, when the gases they pass through this wire, they get negatively charged, because they have there are electrons, there are plenty of electrons on the wire, right. So, they get negatively charged, and when these negatively charged particles, they come into the contact with the plates and plates are grounded. They come into the contact with the plates, give up the charge and they get settled down. So, they are automatically removed from the gas. So, there are compartments, there are number of compartments, plates all are grounded, in between passage the wires are hanging. When the flue gas is blown through the passage, the particles in the gas, they come into the contact with the wire, get charged. The moment they get charged, they are attracted towards the plates because the plates are grounded, and the moment they get attracted to the plate, they stick to the plate, give the charge to the plate and they settle down. That is how it works. And later on, this charge is, sometimes they do not get settled down. There is a steel plug. So, it's steel plug, periodically it removes the particular or the particles from the surface of the plates, right. But care has to be taken. Care has to be taken here is that whatever gas you are pushing in the precipitator, it should be completely burned gas. If it is unburned gas, suppose CO is there or some unburned material is there, it is possible, it is charged, inside it is there is a charge, there is a possibility that this whole entire system may blow out or it may start burning. So, care has to be taken that unburned gases should not enter the electrostatic precipitator, otherwise it is the possibility, there is a possibility it may explode. As I said, efficiency is 90% normally, but if it is properly designed, then efficiency can go up to 99% for the electrostatic precipitator. And it is especially suitable for the power plant where the fly ash density is very high. In those power plants, it is very effective. Another is baghouse filter. In baghouse filter, the process is very simple. In a box, there are number of bags, they are hanging from the header, right. And in the box, the flue gas which enters from the bottom, it comes into the contact with the bags. And when this flue gas, because they are connected at the same header at the top. If you look from the top, it will be looking like this, and all the pipes are connected with the header, right. So, when it comes into contact with this bags and the fly ash particles, they get stick to the bags, right. And this is a very passive type of system. That is why the high filter area is required. Approximately 6.5 meter square per megawatt of area is required for this type of system. Installation cost is also high because passive systems are normally bulky systems. So, installation cost is very high, and mainly this is cloth filter which is being used here. It constitutes around 20% of the total cost. So, it is a costly item, right. And finally, it is blown, this bag is blown, and the dust particle which are stick on the bag, they are collected at the bottom. The next is, as I stated earlier, is thermal pollution. Now, there is a thermal discharge index because everything has to be quantified. So, a thermal discharge index is discharge to environment in megawatt divided by electrical power. Same unit has to be used, megawatt. If you are using a kilowatt, here you will have to use kilowatt. So, heat discharged to the environment divided by electrical power generated. So, this gives us idea for per unit kilowatt or per unit megawatt electrical power generation, how much heat is going to or being discharged to the environment. It is simply quantification of the thermal pollution. So, how to reduce the thermal pollution? Now, the issue is how to reduce the thermal pollution. The thermal pollution can be reduced. We can have, instead of discharging coolant into the river, we can have a separate lake or dedicated lake can be made for this purpose, right? Or some cooling pond may be there, right? From which we can extract the water, right? And after cooling the or after condensation in the condenser, it is sent back to the cooling pond. Or we can go for the cooling tower, that is also another option. Now, after this thermal power plant, we can discuss about the nuclear power plants. Nuclear power plants also, the heat dissipation problem is same. In fact, the water requirement is more in a thermal power plant. It requires a lot of water. Main problem is radiative pollution. Radiation pollution, which comes from the waste material, right? So now scientists are trying to reuse the waste material or leftover fission material in a nuclear power plant, and hopefully in future we may get fuel for the nuclear power plant, which will not generate the waste. It will generate the fuel which can be used in some other form in a nuclear power plant. Now nowadays what we do? Nowadays what in the concrete blocks, this fuel is filled and it is disposed in the sea. It can be diluted also. There are so many ways. I mean, the material we can do atmospheric dilution, sea dilution, absorption by the soil. The best way nowadays is disposal of this nuclear waste material into the sea in concrete blocks. There are pollution, there are environmental issue with the hydro and solar also. Hydro and solar appears to be less damaging the environment, right? But if you look at the hydropower plant, especially when the dam size is large, there is a lot of the submerged area is high, and this submerged, when the surrounding area, normally it is made in a gorge. A gorge is identified where by blocking the flow of the water, the dam is made. When the dam is made, the water level in the river, upstream river rises and it submerges the surrounding areas. So it affects the ecology of the area. Definitely, if it affects hydropower plant, affects the ecology of the area. And when there is a large water body, the large water body, it damps the temperature variation, right? So people are studying this also, how large dams are affecting the local environment, because is it damping damping means the maximum is temperature is less and the minimum temperature is rising. So day range DR means maximum and difference between maximum and minimum temperature in a day. So whether it is shrinking or not due to presence of this water body, a large water body in this area. And second is solar. Solar is also considered to be very environment friendly. But what is happening when you planting, because the energy density of the solar heat is not very high. Solar radiations is not very high. So for a small power generation, you have to occupy a substantial area. And when you are putting an array of solar collectors, so that area is not receiving any heat. Soil is not receiving any heat. And that also has some effects on the environment, right? And many of the other things, the disposal of the solar panel. Nowadays, we are fixing the solar panel, maybe down the 20 or 30 years. These solar panels will become ineffective. They have to be disposed of. So how this solar panel will be disposed of, that is also an issue. I mean, that is also an environment issue. That is all for today on this topic. Thank you very much.